Hey fellow YouTubers, this is N0AGI. I'm here to do a series of videos on this project that I'm working on. Exactly how many parts this will end up being, I'm not quite sure yet, but at least like to kick off the project so we can uh, talk through this and build this together and also discuss some ideas as we build it. So just to set a quick stage and some context, I have two repeaters here in the Twin Cities area. Both of those repeaters are DMR repeaters. They're both deployed at a remote site. So I don't have readily available access to them. So if in case I need to go do some power recycling or whatever, I'll have to gain permissions to go to the site and then do the power recycling and then get out of there. So the task itself of recycling the power takes no more than 5 minutes, but the process of getting to the site is an involved a procedure, which is fine. If the task itself is uh, is um, is about recycling the power, um, I think there's a better way to taking care of that business without having to physically be there at the site. So that's the intent of this project, really, and I'm hoping to have this built out and deployed at the site, at least one site, to do some testing. So let me draw up something here. I have, let's call this site 1 here, and let's call it site number 1. And site number 1 has my repeater. Let's call this DMR repeater number 1. And then of course this thing is plugged into the wall for power. And because this is a DMR repeater and because it's connected to a C bridge, it requires internet connectivity. So today, as of today, I have a T-Mobile SIM card modem that provides the repeater with a internet connectivity. Okay, and the T-Mobile SIM card modem is also plugged into the wall for power supply. So that's the status today. Okay, now one of the reasons why I'd have to go do a power recycle is when T-Mobile changes the dynamically assigned IP address because obviously they provide a DHCP provisioned IP address and they change it every so often. The repeater itself is intelligent enough to pick up the new IP address, but every once in a while it fails to do that. And when that happens, I'll have to go there and do the power recycle. So when the requirement arises for me to go do the power recycle, it's typically when the internet is also down. And which means to say that there is no way for me to leverage the internet connectivity to remotely reset or recycle the power on the repeater. So the notion of using internet is out of the question. Okay, so I think there's a better way to tackle this problem rather than having to be there physically to recycle the power. A more efficient way is to remotely recycle the power. And I think the best way to do that is through APRS as a platform. So let me talk through that a little bit. So first off, like I mentioned earlier, the APRS-IS route to recycling the power is really out of the question because that's not going to work because internet is typically down. And so that's not a viable option. A real option is to use the APRS via RF. A true APRS over RF is what's required to be able to remotely control this power recycling. Okay, so that's a quick context. So what I'm thinking about and how I want to accomplish this is actually fairly straightforward. Um, I'm thinking of installing a very simple handheld 2-meter radio, nothing fancy. Even a Bofang radio would be perfect for this application. This site, the number 1 site, also has my APRS digipeater and iGate. So what I mean by that is the Bofang radio has no trouble receiving packets even while it's inside of this big concrete room where the repeater is sitting in. So that's not an issue at all. So that's Bofang radio. The Bofang radio will then be connected up to a tnc-pi device, and I actually have one of them right now. Actually, it's my second tnc-pi that I will assemble and solder together. So tnc-pi then is connected up to a Raspberry Pi, and the Raspberry Pi is then connected up to a simple relay switch sort of a circuit. So let's call that relay. Okay. So really the workflow is between the radio to tnc-pi, from tnc-pi to RPI, from RPI to relay. And the relay is then connected up to the repeater power cord uh, to manage the power on, power off, power cycling. Okay. All right. So that's the setup on the business side of the on the business end of the project here. Let's call this whole setup N0AGI-R1 APRS node. Okay. I mean, we could call it whatever you want to call it, but let's just call that for the purposes of this discussion. On the user side, let's go back to the user side here. Let's say I have a handheld radio. Let's call this Yaesu FT1D as an example. And I could then send off an APRS message to the N0AGI-R1 node. And the APRS message itself will have a byte command in it. So let's call that a single byte command. Okay. And of course, the message goes from me to this node. So the usual APRS format and the protocol will be followed here. Once I send that message over to the node, the radio receives a packet, and then the tnc-pi intercepts that packet, and the Raspberry Pi then takes a packet, unpacks the packet, and figures out the command. In this case, the byte, let's say that byte is 0. And then depending on what the byte is, the Raspberry Pi can determine whether it wants to turn off the repeater or turn on the repeater or whatever be the case. Okay, so that's a logic behind the workflow. So obviously there will be some control mechanism here so that not everybody can send a command to my to my N0AGI-R1 node and have it reboot or whatever. I'll probably put in some logic in my Raspberry Pi to do some control mechanism so that only select few sender packages or packets are processed for such an operation. Okay, so with that said, I need to mention it here. As a good citizen of ham radio operator community at large, we need to follow all rules and regulations of data that gets transmitted over ham radio frequencies. I just need to make sure that we all understand that we are not allowed to encrypt or compress, more importantly, encrypt any data that gets transmitted on the air. So we will have to send the data as is, and whether that data means something, that's a logical decision. That is something that the Raspberry Pi can take care of, but really the data itself cannot be encrypted by any means. So I just wanted to make sure I mentioned that in this video. All right, so that's a quick workflow. The concept itself is not very unique. It's fairly straightforward. I bet people have done this many times for home automation and things of that nature. This is fairly common practice. I'm just putting in a different angle to it to be able to control the repeater system. Um, One other point I'd like to mention here is you could have, especially about the relay. Let's talk about that quickly. The relay itself is set up as normally closed mode. What I mean by that is the repeater obviously is connected to the relay, and the relay is powered up or is connected to the wall to supply power to the repeater. Uh, and the relay itself is configured or wired up as normally closed. And what that means is the repeater is always on, and it doesn't need the relay. The repeater doesn't need the relay to be on for it to be on, because that would throw additional stress on the relay and the Raspberry Pi circuit. We don't want that. What we want is the repeater to be on by default all the time, and when the relay is turned on, I would like for the repeater to turn off. So really it's the opposite behavior. So if you were to draw a quick truth table here, Raspberry Pi repeater, if Raspberry Pi is off, the repeater is on. That's a default behavior. When the Raspberry Pi is on, the repeater is off. So when a command comes in, let's call it 0, then the Raspberry Pi will ask the relay circuit to be turned on, and then it'll then turn off the repeater, wait for a minute, and then the Raspberry Pi will quickly turn off the repeater relay, and by which the repeater will then go back to on status. So that's really the simple logic behind it. Now you could have multiple relays in here. You could have multiple relays in here, one to control the repeater, one to control, let's say, a T-Mobile modem, whatever be it. So that way you'll have a better surgical access to each of these devices through each of these relay circuits. So really, that's it. I just want to kind of talk about this idea, and my next steps is to get the hardware set up, and from the hardware standpoint, get the Bofang radio, prepare this custom connector cable between the radio and the tnc-pi. And from the tnc-pi to RPI, there's no special connectivity other than assembling my tnc-pi. And then I'll have to prepare a very simple relay circuitry between Raspberry Pi and the relay box itself. And of course, customizing the power cord so that the relay can control the power cord between on and off status. So that's the hardware. I think it's important to talk here about the software on the business end of it. And that would be, I'm a big fan of APRX software, and I think you've seen my previous videos on APRX. APRX runs really cool. I think it's a very easy software to manage. It runs off of a config file. It's easy to set up. It's really, I call it completely autopilot. Super impressed with that product, and people there have done a phenomenal job of producing the product and keeping up the product. So many thanks go to them. So I'm a big fan of APRX software. The other piece, I could actually go direct to AX25 protocol, which is really far more closer to the hardware. And by that, what I can then do is I can have the Raspberry Pi easily unpack the AX25 packet and then decipher the command and process it. So that's fairly straightforward to work directly off of AX25 pipe and get the work done that way also. So I'm probably more leaning toward that because it's just fairly straightforward. It's inherent as part of tnc-pi. So this data and the protocol is readily available, and I don't have to then go to the APRX software. Last but not least, I'll probably have some C and Python coding involved. Um, that's really it. So outside of that, it's fairly straightforward, as you can tell. Nothing fancy going on here. Um, I might build, I might build in some additional response system back from the one second here, a response system back from the site APRS node back to the user, so that so that it can relay the status back to the sender about what's going on with the status of the power cycling. Maybe some additional features like notifying, sending an additional APRS message to the owner of the site, or rather the repeater at the site. That can be another option. So the possibilities are many, but I'd at least like to start with version 1.0, and the version 1.0 will provide a basic functionality to get this up and running. So with that, thanks so much for watching, and please do provide any comments, feedback, etc. would be valuable. And look forward to seeing you all in part number 2. Thanks for watching. We'll talk soon.